Welcome back to Zoom Zoom channel. Before we begin, don't forget to like, subscribe, and turn on the bell so you never miss any of our exciting animal videos. Gorillas are not the fastest animals, and they are not the deadliest predators, yet they are among the strongest creatures in the wild. So what makes them so powerful? In today's video, we'll uncover the real reason gorillas are so strong and break down the science behind their incredible strength. You often see bold claims on the internet that seem to make complex ideas simple. One very popular claim states that a gorilla is precisely 20 times stronger than a human. That number sounds clear and definitive, making it easy to repeat and share widely. But the truth is, that number is not a reliable scientific fact, and it oversimplifies a much more interesting reality. Scientists who study animal strength do not agree on one single exact multiplier for gorilla power. The tasks used to measure strength can vary so much. Pulling a rope, lifting a weight. A more cautious estimate suggests a gorilla's upper body may be about 6 times as strong as a human's. Even this figure is only an estimate. It is far safer and more scientifically honest to avoid specific numbers altogether. The most immediate and obvious reason for a gorilla's strength is its sheer size and its body composition, especially the upper half. Gorillas have incredibly large, robust upper bodies. Their chests are broad and deep, shaped like a barrel, a massive framework of bone, dense, powerful muscle. Their shoulders are exceptionally wide, giving a stable, powerful base for the arms. This entire torso is a powerhouse, not built for the slender grace of a runner, but for raw, functional strength in a dense, three-dimensional forest. Their arms are another key component, both long and heavily muscled. In many adults, especially silverback males, arms are longer relative to legs than in humans. That length gives an extended reach, used for climbing and for pulling down branches to reach food. Arm muscles, grappling, a physique for immense force in short, powerful bursts, bending a thick bamboo stalk to reach shoots, breaking a bamboo stalk, routine tasks, generally lighter and less muscular relative to our legs. Evolution shapes animals for their ecological niche. The gorilla's large upper body is the result of generations of adaptation. It's the foundation for all their other strength traits, a body built for power. Beyond the general size of their upper body, the specific shape and structure of a gorilla's shoulders play a critical role in their incredible pulling power. In simple terms, their shoulders are anatomically specialized to pull with tremendous force. The shoulder blade, or scapula, is positioned on a gorilla's back, providing a more stable platform for the large muscles that connect the torso to the arm. This arrangement gives them a mechanical advantage, translating muscle contraction into powerful pulling motions more efficiently than a human can. Some of the large muscles around the shoulder, like the latissimus dorsi, the trapezius, are exceptionally well developed with attachment points that give better leverage. Leverage here means muscles can apply greater force to the arm for the same effort, like using a long wrench to turn a stubborn bolt. In gorillas, muscle placement and size act like a built-in biological wrench, maximizing force for pulling themselves up a tree, tearing apart dense vegetation. Human shoulders, by contrast, are built for a different purpose: wide, versatile motion. We can throw with speed and accuracy, reach in almost any direction, perform intricate tasks. That flexibility costs raw, linear pulling strength. A gorilla's shoulder is a specialist tool, honed for force. A human shoulder is a generalist tool, adapted for versatility. That explains why a gorilla can pull down a heavy branch or overpower a rival. This specialization shows up in everything they do. When they climb, they don't just lift their weight, they pull it up with their arms. When they chest beat, the motion starts in the back and shoulder muscles. When foraging, they use pulling strength to access otherwise unreachable food. Their shoulders are biomechanically engineered for pulling, a cornerstone of their physical prowess and evolution. Another fundamental reason for a gorilla's immense strength is the simple, constant work of moving its own heavy body. An adult male gorilla, or silverback, typically weighs between 300 and 485 pounds, approximately 140 to 220 kilograms, with some individuals growing even larger. Females are smaller but still possess significant mass. Carrying this substantial weight through a dense and often steep forest environment is a form of resistance training that they perform every single day of their lives. This daily effort ensures that their muscles, bones, connective tissues remain incredibly strong and robust. Imagine carrying the weight of 2 adult humans or 3 adult humans everywhere you go, not on flat pavement but up and down hills, through tangled undergrowth, over uneven terrain. This is the reality for a gorilla. Every step they take, every time they climb a slight incline, every instance they push through thick plants, their arms, legs, core muscles are engaged in heavy work. This constant physical demand has shaped their bodies over many generations. Evolution has favored gorillas with the muscle power necessary to move their heavy frames with agility and control. The sheer mass of a gorilla also becomes a powerful tool in itself. In a confrontation with a predator or a rival gorilla, their body weight provides tremendous momentum and stability. When a silverback charges, the force it generates is a product of both its muscle power and its massive weight. This makes their displays of strength effective at intimidating rivals and protecting their family group from threats. Their weight is not a burden but an asset, a physical presence that commands respect, reinforcing their dominant role within their social structure and the broader forest ecosystem. Therefore, the great weight of a gorilla is both a cause and a consequence of its strength. It requires immense power to move, building and maintaining a strong physique through constant daily effort. At the same time, that weight contributes directly to the force they can exert, making them formidable in any physical contest. This dynamic relationship between mass and muscle is a key part of their biology. A gorilla is strong not just because it has big muscles, but because it has to be strong to simply carry itself through the world. A true forest giant in every sense of the word. The unique way gorillas move on the ground, known as knuckle walking, places extreme, continuous demands on their forelimbs. It contributes significantly to their upper body strength. When a gorilla walks, it doesn't use flat palms like a bear or walk upright like a human. Instead, it curls its fingers and supports its front on thick, calloused middle knuckles. The hands, the wrists, the forearms, the shoulders all bear a huge portion of body weight, not just when standing, also while moving. It's a constant, low-intensity workout for the upper body. Gorilla wrist bones are fused, locked into a stable, weight-bearing position, preventing joint collapse under pressure. That skeletal design is backed by powerful muscles and thick ligaments across the forearms and shoulder girdle. Over time, repetitive knuckle walking builds dense bones and powerful musculature, hallmarks of a gorilla's physique. It favors animals with tough forelimbs, powerful forelimbs, resilient forelimbs. Think of it as a gorilla gymnast on the pommel horse or on the parallel bars. The arms aren't just for propulsion, they're pillars of support. Unlike humans' bipedal walking, where the arms are free and the legs bear the weight, for gorillas the arms are always in. The specific shape of their bones, the exact points where muscles attach, play a crucial role in generating force. This is called biomechanical leverage. In gorillas, major muscles connect to the bones of the arm and the shoulder in positions that give a mechanical advantage. That advantage lets them produce much more torque. Torque is the rotational force that moves a joint. Think of opening a heavy door. Pushing near the hinges takes a lot of force. Pushing at the far edge makes it much easier. That's better leverage. In gorillas, some muscle attachments sit farther from the joint they move. So, the same muscle contraction produces far greater force at the hand or arm. Their bodies are built to extract more power from each muscular effort. This contrasts sharply with humans. Human muscle attachments favor speed of movement and a wide range of motion rather than max force. For example, throwing a ball relies on attachments tuned for speed. Gorillas make the opposite trade-off. They sacrifice some speed and fine control to generate brute force for tasks like breaking thick branches uprooting plants, defending their territory. The sheer size of their muscles is impressive, but it's this hidden architectural advantage that multiplies power. It's a subtle but crucial detail. Strength isn't just muscle mass, it's the full system. Bones, joints, muscle attachments. Together they form an efficient, force-producing machine. Gorillas' musculoskeletal system is shaped for optimal leverage, turning their bodies into powerful levers. Finally, a gorilla's immense strength is supported by its diet and driven by the social needs of its group. To maintain such a large, muscular body, an adult male gorilla must consume a tremendous amount of food each day. They can eat up to 40 pounds, about 18 kilograms, or more of plant material, including a variety of leaves, stems, pith, some fruit. This largely vegetarian diet provides the vast number of calories and nutrients required to fuel their metabolism and preserve their massive frame. They spend a significant portion of their day foraging and eating, a constant effort to power their incredible biological engine. This steady intake of high-volume fibrous plant matter is processed efficiently by their specialized digestive system. Beyond the physical need for fuel, their strength serves a vital social purpose. In a typical gorilla group, a single dominant male, the silverback, is responsible for protecting the entire family. His strength is his most important tool for defending the group from predators, like leopards, or from rival males who might try to take over. This protective role means that power is not just for show. It is essential for the survival and well-being of his offspring and the females in his care. His impressive size and strength act as a powerful deterrent, often preventing conflicts before they even begin. In conclusion, the incredible power of a gorilla is not the result of a single trait, but a combination of many interconnected factors. They are not built for precise, isolated lifts like a human weightlifter in a gym. They are built for applying practical, overwhelming force. From their massive upper bodies and specialized shoulders to their heavy weight and knuckle-walking posture, every aspect of their anatomy is geared toward power. Evolution has meticulously shaped the gorilla body for a life that demands immense strength in the arms and shoulders, and it is in this complete biological picture, not in an exaggerated number, that the real story of their power is told. We can simply state a clear fact: gorillas are vastly stronger than humans. Arms, shoulders, back. Their entire anatomy is designed for generating powerful force. The human body, by contrast, is designed for endurance. Instead of hunting for a magic number that does not exist, we can learn much more by looking at the gorilla itself. Why are they so strong? The answers are written all over their bodies: shape of their bones, size of their muscles. Their daily lives contribute to their strength. Their diet contributes to their strength. Their social structure contributes to their strength. By examining these real, observable facts, we can gain a deeper and more accurate appreciation for their strength. It is a story not of simple multipliers, evolutionary design, biological function working in harmony. Understanding this helps us move beyond sensational headlines and toward genuine respect. Their strength isn't a superpower for us to measure in a contest. It is a fundamental part of who they are, a tool that has allowed them to thrive in their forest environment for countless generations. The real story of gorilla strength is not found in a number, but in the intricate details of their biology. Let us now leave the myths behind and explore the real reasons for their formidable power, starting with the very frame of their bodies.